There are different outcomes that you can get with these equations. The two that we've seen so far have been the more typical outcome. It's the case where you solve it and you get a solution. Those are called conditional equations because they're true under that given condition. You know, like if we go back to this equation is true under the condition that x is equal to negative 20 over 3. So this is a conditional equation. So on some of these homework problems, they're going to ask you, what type of equation did you just work with? And in this case, we would say we worked with a conditional equation. We solved it, we got an answer, that's conditional. Right? A conditional equation is an equation with a finite number of solutions. So most people have encountered the word infinite or infinity, and they're familiar with that term and they know how to say it. But I'm often surprised that many students have not encountered the opposite of that word, which is pronounced finite, which just means not infinite. So getting one solution that's not infinite, that makes it a conditional equation. If you had 5 solutions, if you solved an equation and got 5 solutions, which would be a pretty tough equation, but if you only got 5 solutions, even though it's a lot of solutions, it's still conditional because it's not infinite, right? It's finite. 5. Even 100 solutions would be finite, right? But in this section, for most of these problems, if you get one answer, it's conditional. We will be seeing an equation that gives you 2 answers later, and it's not going to ask you, but in those cases, those are also conditional, right? If you get 2 solutions, that's still a conditional equation. As long as you get solutions and it's not infinite, it's conditional. But there are 2 other possibilities. One possibility is that you could try to solve an equation and find that there are an infinite number of solutions. We haven't seen an example of that yet, but we're going to. That is called an identity. Because what's going on there essentially is the left-hand side is identical to the right-hand side, which means it's always going to be true no matter what number you plug in. If the left-hand side matches the right-hand side, the values are always going to match. So any number is going to make it true. And so you get an infinite number of solutions that way. Or almost any number. We're going to see a type of equation where there's still numbers you can't use, but any number you can use will make it true, so it's still infinite. And we call those identities. The other possibility is that you get an equation that has no solution, that is impossible to make true. No matter what number you choose for x, the left-hand side will never match the right-hand side. It'll never be a true statement. And those are called inconsistent equations. We haven't seen an example of that yet either, but we will. All right, so inconsistent is the other case. So these are special cases, and we'll talk about how to recognize in your equation when you have one of those special cases. All right, so let's take a look at this example. So we have 4 times parentheses x minus 6 equals 4x plus 24. And so we'll start by distributing the 4, right? You can't solve for x while it's stuck in the parentheses. So we distribute the 4, we'll get 4x, right? 4 times x is 4x. 4 times negative 6 will be negative 24. The right-hand side doesn't change, but I copy it here anyways, because I just want to be clear and consistent and thorough in writing out the problem. And then the next step, again, this is where my focus goes, is I want to deal with the variable first, and then I'll deal with the numbers, the constant terms second. I want to get all my x's on one side of the equation. So I will get rid of the x from the right-hand side by subtracting 4x. That'll cancel it out from the right-hand side. But to balance out that operation, I have to do the same thing to the left-hand side. Right? And so here, clearly those cancel out, and we end up with 24 on the right-hand side. But sometimes students just can't let go of that variable, or they're just not used to it disappearing like this. And so I will oftentimes get students that still write an x here. Like that's just what they expect to see, so they're just going to write it there anyways. But if it cancels out from the right-hand side, right, 4x minus 4x, x is just gone. It disappears. It's going to happen over here also because it's the same situation. 4x minus 4x, the x's are just going to go away. So let me just erase that x I just wrote. It disappears from the left-hand side as well. And what we're left with is negative 24 on the left-hand side. And so let me write that over here. We got negative 24 on the left-hand side, positive 24 on the right-hand side. So this is how you know when a special case is occurring. In solving the equation, if your variables completely disappear from the entire equation, they just vanish, then it's going to be a special case. And either you have infinitely many solutions or you have no solutions. So it's really polar opposites here. It's going to be one opposite or the other. And the way you know which one it should be is by looking at the result that you get after the variables have vanished. Here I'm getting negative 24 equals positive 24, which is a false statement. Right? That is not true. Negative 24 does not equal positive 24. And so the way I like to word this is I say, this is always false. Negative 24 will never equal positive 24, which means the original equation is always false. No matter what you plug in for x, it's always going to be false also, because these are equivalent statements, right? Whenever you take an equation and you manipulate it and you solve it and you do things, to the left-hand side and the right-hand side, as long as you balance it out, each resulting step is equivalent to the step before it. And so negative 24 equals positive 24 is logically equivalent to this equation. 4 times x minus 6 equals 4x plus 24. These are logically equivalent to each other. If this is always false, this will always be false. So no matter what I plug in for x, I can never make this equation true, which means this equation has no solutions. If this comes out as true, then this is always true, which means my original equation is always true, in which case we have infinitely many solutions. So that's how you tell the difference. The variable disappears. If it's false, it's no solution. If it's true, it's infinitely many solutions. All right, so no solution. So we have a lot of options down here. Which option do I want to pick? They don't usually word it in this way, and the wording will change slightly from problem to problem, but in this case, they're calling it the empty set. The solution set is the empty set. That's the case where there's no solution. And then it's not on the screen, but it's in the directions. Identify the equation as identity, inconsistent, or conditional. And in this case, if there's no solution, that means it's inconsistent. And that's the option you would want to pick in Math Excel when you're answering the question. All right, so going back to this, it's an identity if, well, let me kind of put it like this. The variable, if the variable in your equation disappears and the result is, let me scroll down here. If the result is colon, one possibility is true, it's an identity, and there's infinitely many solutions. If the result is false, it's inconsistent. All right, so that's probably the simplest way I can think of breaking it down so that you just sort of have a rule to follow.